What's up, guys? This is Mr. Carlson. Welcome back to Algebra 2.1. We are going to learn about 2 by 2 linear systems. How can I solve two equations with two variables in them? And what does it mean to even solve it? So let's go through, actually, you know what? We'll probably skip the bell work, but let's just go through the objective essential question, 2 by 2 linear systems, and closure homework. I'm going to skip the bell arc just because it's a lot of questions that we've already reviewed before using functions, graphing functions, rate of change. So I'm not going to go through that. So let's just jump here. Essential question, what are the three ways to solve a 2 by 2 linear system and how do you choose which method to use? Okay, that's very important. How do I choose which method to use? It depends. Okay, we're going to see what that is. A lot of this should be reviewed from Algebra 1. Maybe we remember using what we call substitution or addition method slash elimination. Okay, my favorite is substitution. And so when you have to solve this system, but your partner insists on using the substitution method, clearly, probably this is better for elimination if you remember, but if not, that's okay. We're going to go through it. Okay, so there are three ways, guys, to solve. Make sure you have your notes out. Make sure you are following along. There are three ways to solve a system of two equations with two variables. And yes, like I said, this is technically Algebra 1 review, just slightly. There's graphing, which is very easy. That's why we have Desmos. Okay, I'm going to show you how to use Desmos, graph, and what we're actually solving for. There's substitution, which is my favorite because it's used in higher level mathematics. And then elimination, combination, or what we call the addition method. So I bolded these things just because they're probably the easiest to use. Graphing, of course, is the easiest, especially if we have Desmos. However, I'm going to be showing you more often than not the examples for substitution, elimination, and addition way more, okay? So this is the only example I have with regards to graphing because it's so simple. I won't be using Desmos that much, only to show you that it does work, okay? But most of the time I'll be doing it by hand, and you are still required to take notes no matter what, okay? So how do I do this? Well, first of all, I need it in y equals mx plus b form. That's the easiest way to graph it. Now, I could graph the intercepts here. That is definitely available to me. I could definitely graph the intercepts. And I could, but if I want to know where these intersect, that's where I probably should be using y equals mx plus b. So what do I mean by intersect? Well, that's the solution. So first of all, let's solve this one and put it in y equals mx plus b, and then we'll see what the solution really means. So in order to put this back in y equals mx plus b, the slope-intercept form, to find the slope, to find the intercept form, what I need to do is I need to isolate that y. So I need to actually move that x over. So what I have is 2y equals, and then negative x, and then plus 2. So I subtracted the x over on the other side of the equal sign. Divide by 2, divide by 2, divide by 2. So now that goes poofy, and so now I'm left with y equals negative 1 half times x, and then plus 1. Okay, so this is my red line. Okay, so let's graph it. So my b right now, my y-intercept is 1, and my slope is negative 1 half. So b is 1. Oops, not right there. That's my x-axis. Shouldn't be putting it right there. So b is 1 right here. And if I go down 1 over 2, that is where it crosses. Now, if I just did my x-intercept and y-intercept plot points, so if I plugged in 0 for x, plugged in 0 for y, and now I would find where it crosses the x and y axis. That's what we learned during the lesson of rate of change graphing functions last week. I could definitely do that, and I can make my line. But the problem is I need to make sure I actually build off those points with my slope. And it's really hard to see what the slope is right here until you actually put it in slope-intercept form. Okay, so I go down over 2, go down over 2, go down over 2. And let's just go up a couple ones. So up 1 over 2, up 1 over 2. That looks pretty good. Okay, so let's see if I can do this. Not bad. I mean, let's be honest, I've had worse, right? Okay, now that that line's done, let's do this one in blue. Same thing, y equals mx plus b form, so negative 2y equals negative x plus 6. Divide by negative 2, divide by negative 2, divide by negative 2, that goes poofy. This becomes y equals poofy poofy, so 1/2 x and then minus 3. This is my blue line. So my blue line is negative 3, that's my b value. And then my m value is 1/2. So my b value, negative 3 down here. And now, since it's a positive slope, it goes up. So 1 all over 2, 1 all over 2. And right here, we start to see something interesting. Okay, I'll do a couple more just to get a nice line. Okay. This one's not going to be as nice. Okay, right here. What is that? That is where they intersect. So what's that point? 4, negative 1. So this point is 4 comma negative 1. This is actually my answer, my full answer. Okay, I know you're like, oh, graphing isn't your answer. No, technically it's the means to get to my answer. It's the way we get to my answer. My answer is this, okay, literally the ordered pair 4 comma negative 1, where x equals 4 and then my y equals negative 1, okay? So what does this mean? This is the actual solution. This is a solution set, okay? Which means the solution to these equations, these two equations, two variable equations, hence 2 by 2, two variable, two equation linear system, okay? This right here, the solution set, when solved, is this, okay? Now, if I graphed it on Desmos, I just want to show you. I won't do this every time, but I will show it to you now. So if I graph those literal equations, x plus 2y equals 2. And then my next one was x minus 2y equals 6. Okay? My first one was red, my next one was blue, just like what I have here, right? You see it? Same exact thing, right? Now watch. What is that point? That point is the same point that we got when we graphed it by hand, 4, negative 1. Okay, so 4, negative 1, 4, negative 1. This is my solution set. Now, we didn't even need to put that in y equals mx plus b form. That's the beauty of it. Okay, we can just straight up go to Desmos and plug it in. So while I don't necessarily encourage you going straight to Desmos to plug it in, it is extremely beneficial, okay, especially if you're stuck. Notice also here are the points. These points were also my intercepts. If I go over here, they crossed at 0, 1, and 2, 0. But that's exactly what we had here, 0, 1, 2, 0. All right? Like I said, Desmos is a helpful tool. If you haven't been using Desmos, if you haven't even made your own account, I strongly encourage you to do that because it helps, okay? Then you can save this graph to your own account and you can keep coming back to it over and over and over and over again. It is very beneficial, okay? So again, I'm not going to show you how to do all these examples on Desmos. I'm going to show you the actual algebra, not the graph behind it, but the actual algebra behind it. So that's mainly what we're going to be doing today. However, your graphing on Desmos does help. So let me erase this and let's continue. This is now going to get into substitution. How do I solve 2 by 2 linear systems using substitution? Well, I'm going to show you it algebraically, and then I'm going to go back to Desmos, and I'm going to show you how to do it just by plugging it straight up in, just like what we did, and find the solution set, find the answer just graphically, okay? But I'll probably stop after this one. I just want to let you know that Desmos literally will always give you the solution set, always, 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 no matter what, as long as you're plugging it in correctly. It doesn't matter if this is in y equals mx plus b form. But getting back to the point, substitution, solve one of the equations for one of its variables. That's the first thing. Next thing is we're going to substitute the expression for the variable in the other equation. Third, solve the remaining variable. And then fourth, substitute that value into the other variable. What does that mean? Well, it means this. This is a good method for substitution, not just because they tell us, substitution method, okay? Not just because they tell us, but because there's one variable that technically has no coefficient, and that is this x. Substitution method is a good method when there's no coefficient, okay? Substitution method is a great method when there's no coefficient for that variable. So memorize that, know that. When there's no coefficient, and that answers our essential question actually, when there's no coefficient, that's when the substitution method is probably the best. So how do I solve this? Well, first off, let's isolate this x. So x equals 5y. Now that that's isolated, I'm going to take this expression and plug it in to that x, okay? Not to itself, or else it's going to be in a circular reasoning. You can't just take that and plug it into yourself. You have to take that and plug it into something else, okay? Meaning the other equation, okay? So that means what I get is now 5, and then literally in red here is what's going to be plugged in. If this is x, and this is what x equals, then I'm going to plug in 5y. So that's what I'm plugging in. And then plus 3y equals 0. Now notice how the x went away. You can't solve for one variable, guys, or two different variables. You can't solve for two different variables. You can solve for one variable, though. And in this case, we can solve for y, but you can't solve for two different variables. In the equation right here, there's two variables, x and y. And you can't solve for both of them at the same time. So what we need to do is manipulate one of these equations, such as the bottom one, as we did, and then use that to solve for my other variables. So now what is this? Well, 5 times 5 is 25. Y plus 3y equals 0. This is 28. Y equals 0. And so y, of course, equals 0 when I divide by 28. Now, 0 is still a number, guys. Just because it's 0, it has no value. That doesn't mean it's not a number. Okay, now what do? Well, now I take that 0 and I plug it in. I plug it in, perhaps, to this. I want to find what x is, right? And this says x equals. So now what I can do is just x equals 5. And then I'm plugging in, again, what y equals. So 5 times 0. So my red here is the substitution. And of course, when I multiply this out, this equals 0. So what's my point? My final point, my final answer is 0 for x, comma 0 for y. This is my final answer. You should definitely plug it into a point like this. If you don't plug it into a point like this, I'm pretty sure Math Excel will mark it wrong. They want you to plug in this, the solution set. So make sure for Math Excel, you plug in this, the solution set, because this is the solution set, okay? That's right. All right, let's move on. Let's do a couple more. More on substitution. Let's go to town. So I noticed right here that this variable doesn't have a coefficient, so it's easy to substitute. So I'm going to substitute this, but first I need to isolate that variable. So that means negative y equals negative 3x and then plus 22. And then I divide by negative 1 to everything. So that means I get y equals positive 3x minus 22. So change the signs. I take this and I plug it into the top equation right here for y. Why do I do that? It's because this says y equals. Okay, so now what do I have in my top equation? 2x plus 8. And then right here in red, what I'm plugging in is this for my y. If y is that, and this is what y equals, we can just interchange them. They mean the same thing, is essentially what equals mean. So they mean the same thing, we can just interchange them. So that means this is 3x minus 22. So my substitution is in red, and then we finish out the rest of the equation, negative 20. Okay, so now what will this look like? This simplifies, and now notice you have x and x. There's no more y's. There's one variable we can solve. So now this is 2x plus 24x, and then minus, what is 8 times 22? So 8 times 22, if you want to go on Desmos.com, you can do that, but this is 176. Or you can just use your fancy calculator. By the way, if you have yet to get a TI-36X Pro, I would highly encourage you to get a TI-36X Pro. Just saying. It's very helpful. Okay? But yes, that's 176, and then minus 20, of course. Just tagging on the end. Let's simplify this. This is 26x. Let's add the 176 over. So this will be 156. And then divided by 26, divided by 26. That goes poofy. This actually becomes x equals 6 when I divide those two numbers, which is pretty good. Now, what do I do here? Well, now what I can do is I can plug in this x for that x, because that says y equals already, right? So y equals 3, and then in red is my substitution, so 6. And then I need to finish out the rest of my equation, which is minus 22. So this equals 18, and then minus minus 22, and this equals negative 4. So what's my answer? What's the foremost answer? My x value is 6. My y value is negative 4. So in blue, with this smiley face, is your final answer. Okay? So this seems pretty chill, to be honest. It seems pretty chill. Those are the only ones that I'm going to go over with substitution. Okay? And because I promised you, I'm going to take this one and I'm actually going to plug it into Desmos. I'm going to show you that you'll get the same answer no matter what, even if you didn't work out all the math. Okay? So let's go straight to Desmos. Our answer is 6, negative 4. That is where they cross. So let's turn off these. Let's type in 2x and then plus 8y, and then equals 22, negative 20. That's my first one. And then the next one I had was 3x, and then minus y, and then equals 22. That was my second one. So let's see what they have here. So I go over here, and now if I press, and voila. Okay, that is exactly what we got. 6, negative 4. So what we had right here, 6, negative 4, just algebraically. We didn't graph anything. We just solved it algebraically. And yet when we put them into Desmos, exactly how we see it, without even substituting in anything, we still get this. Even if we plugged in our solved for y value, so y equals 3x minus 22, it's still the exact same one. See? This is the black line. This is what we solved for. This is what we had when we solved for y, but notice it's the exact same line as the purple. I can take the purple away. Okay? They're the exact same line. Right? So that means that this one, the purple and black lines are the exact same, and we still have a point that intersects. That is my solution set. That is my answer. The whole thing, including the parentheses. Okay? I'm not going to show you that anymore on Desmos, but feel free to always double check your work on Desmos to see if you have the right answer. Okay? Feel free. Or if a question is too hard for you, if you feel like you want to just plug in a Desmos to get the answer, by all means. Don't think it's cheating. Okay? It's not. It's using your resources. Okay? This is Desmos.com. It's an educational website. It's not like Math Papa or Mathway or Photomath, okay, or Math Tiger or whatever. This is an actual educational website, okay? It is there to help you understand how the math works. So let's move on. Let's erase. Now let's go through elimination. also called what the homework calls addition method. First things first, and a lot of people may like the elimination method better. It's just a tad bit more complicated, and it's a little bit more work, I think. But put both equations in standard form. Standard form, by the way, is this. So ax plus by equals c. So that is standard form, just FYI. Next, multiply one or both equations to get the opposite coefficients. What's the opposite? So the opposite is one that's positive or one that's negative. Okay? One that's positive, one that's negative. That's what opposite means, and it needs to be the same coefficient of one of the variables. Add, that's why it's called the addition method, add both equations together to eliminate the variable, and then solve the remaining equation. After that, you're going to substitute. After solving the remaining equation, you're going to substitute and solve for the remaining variable. So go through these steps, and I encourage you to actually follow them along. I may not write them out on the side, but as I'm going, I may not do step 1, step 2, step 3, but I encourage you to still see where our steps are going and what we're doing to get our steps. So this one's actually fairly simple, and the reason why this one's fairly simple is because it already has opposite coefficients on the y. Okay? So step 1 is already done. Step 1 is already done. Step 2 is already done, technically. Okay? So really, both of these steps are solid. We're now starting with step 3. And that's what we're going to do. We're going to now add. Okay? I noticed that the y variables are already opposite coefficients. So when I add them down, the whole thing, when I add this, add that, these go poofy. This becomes 7x, then equals, and then this right here becomes 28. I don't know why I have a 3. Whoops. Divide by 7. Divide by 7, that goes poofy. X equals 4. So this one was nice. Okay, I would definitely not use substitution on this method. Now notice substitution is not good on this method because there's no coefficient that is just 1 here. There's no variable that has a coefficient of 1. Okay, usually when we do substitution, it's like x and then plus 2y equals 7, and then 7y plus like 10x equals 5. I don't know. I'm just making something up. Notice how it doesn't seem like it has a coefficient, and sometimes we do say there's no coefficient there, just kicks and giggles, but there is technically a coefficient there, and that coefficient is 1. This would be a great opportunity to do substitution. But since we're not doing substitution, and since we don't have that opportunity, we're not going to do that, okay? So let's look back at our problem. We have this. Now, does it matter? I always have students ask, does it matter which equation I plug this in? No, it doesn't. It doesn't matter which equation you plug it in at, okay? So I'm just going to choose this one. It doesn't matter. So that means 3, and then in red is my substitution, okay? 3x, which is 3 times 4, and then the remaining equation I have is minus 12y equals 12. So let's solve this. This is 12 minus 12y equals 12. I subtract the 12 over, so that means I get negative 12y equals 0. And of course, that means y equals 0. So what's my final answer? Final? 4 comma 0. That's my final answer. Okay? So this one was not many steps, to be honest. It looks like a lot of steps, but that one was easy. All right, so let's erase this. Let's go through one more, a little bit more complicated one. Now this one is really, really good for substitution. Look at that, coefficient of 1 right there. So it's really, really solid for substitution, but since we're still doing the addition method or the elimination method, we're just going to continue, okay? We're going to continue doing that. So I look at this and I'm like, okay, what's the easiest way? Okay, so far they're already in standard form. Okay, what do I multiply by? Now think about this. you could multiply and eliminate the y's. You can absolutely do that. If I did and eliminated the y's, I would need to multiply this by 5, and I would need to multiply this by 3, because I need to get opposite coefficients. I need to basically find the LCM, the least common multiple. In this case, it would be 15, okay? Because that is the first number, the very first number that divides these numbers evenly. 15 divides 3 evenly. 15 divides 5 evenly, okay? So that's what I mean. So you divide it, they divide it into 15 evenly. So that's why I'm choosing these numbers, all right? Now, in order to make it better, I would need to choose either one to be a negative. It doesn't matter which one I make a negative. Now, but if I did this, would I get big numbers? And that seems like a lot of work. I would have to multiply like both of these equations. And 5 times negative 11, I mean, that seems pretty big. 3 times 16, that's like 48. So those are pretty big numbers, is what I'm saying. Okay? So what's a different way to do this? Well, there is a different way to do it, and I'll show you. And this is just practice, guys, getting skill at the math. Let's just multiply this one by eliminating the x. Who says we need to eliminate the y? We don't need to just eliminate the y. We can eliminate the x. And we can multiply this x by 4. So now the 4's are actually together. It doesn't matter which one becomes a negative. No. Let's just make this one a negative because we're already multiplying it. We're already changing it. So now my new equation, when I multiply this negative 4 all the way through to all three terms, is negative 4x minus 12y equals negative 4 times negative 11 is a positive 44. And now this one I haven't changed at all, so I'm just going to drag it over so I can have nice, neat, clean math. And now what I can do is finally add them. So when I add them, now the 4x's go poofy, and then negative 12 plus 5 is negative 7, and then I tag the y on it, and this becomes 28. 44 minus 16. 44 minus 16 is 28. Divide by negative 7, divide by negative 7. That goes poofy. I have y equals negative 4. Okay? Now, of course, now I can just plug it into anything. Let's just plug into the bottom one. It doesn't really matter. Some of you may be thinking, oh, the top one is great. It doesn't matter which one you plug it in. I'm just going to plug it in the bottom. So 4x plus 5, and then times negative 4, and then equals negative 16. This is negative 20, negative 16. Put my 4x down here. And then I'm going to add that 20 over. So that becomes 4. Divide by 4, divide by 4, x equals 4. Doesn't matter if you plug it in the first one, the original one right here, or if you just plugged it into the other one, okay, like what I did. What's my final answer? 4, comma, negative 4. Okay, that's what Math Excel will want with the smiley face. Okay, awesome. So now let's get into what we call solution sets. Solution sets, there's technically 3 different types of solution sets. There's one solution set that says you have a solution. That's what we got right now. It's called a unique or conditional solution set. So what we just did was what is called a conditional, or sometimes it's often called unique solution set. That's the most common. Okay, that's literally finding x, y. So an example of that is x comma y. We find an x comma y and we're solid. Okay, but sometimes it doesn't work out that way. Sometimes we get a no solution. And that happens if both variables drop out and you're left with what's called a false equation. What's a false equation? False equation is something like x equals no, let's do a better one. Something like this, 0 equals 1. Or 0 equals 5. Or 5 equals 7. Or 10 equals 8. You get the picture? Does 0 equal 1? No. Does 5 equal 0? No. Does 5 equal 7? No. Does 10 equal 8? No. Okay, this is what's called a false equation or false solution set. Now, infinitely many solution sets is if both variables drop out. So that means both variables drop out, but that also means we have parallel lines. Okay, both variables drop out. That's infinitely many solution because that means they're not parallel lines. My bad. That means they're actually the same line. Now I'll show you what that means in a little bit. That means they're literally the same line. A no solution set, is the parallel lines. So a no solution set is when they don't cross at all, when they don't even intersect at all. That's a no solution. And I'll show you on Desmos. Infinitely many is where they actually cross, but many, many, many times because every single x value on those lines are another solution. So let's go through here. Let's just solve it with any method of any choice. Since it's already kind of isolated right here, I'm just going to take that x and I'm going to solve it using substitution. So negative 2 times, substitute that 2y minus 6 in here, and then plus 4y equals 12. I want to distribute, so negative 4y, and then plus 12, and then plus 4y equals 12. Negative 4y and plus 4y go poofy, and so now I'm left with 12 equals 12. Okay? This is exactly what you're given. Okay? This is exactly what you're given. So 12 equals 12 is an example of what's called an infinitely many solution sets. Okay? Infinitely many solution set, whatever. So this is what we call, I'm just going to abbreviate, infinitely many. Now, why is it infinitely many? Let's go to Desmos to find out. Let's graph these two lines exactly how we see it in black and then see what's going on. So let's turn off these lines. Let's go over here and let's type in x equals 2y minus 6. My next line is going to be negative 2x and then plus 4y and then equals 12. Okay. We zoom out and now what we get is this. Now notice, what do you notice? They are the exact same line. I'm talking off the blue right now, as you see them right here, and I see red, but that's the same line as this blue. Boom, 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 boom. They're the exact same line. If I simplified this blue equation, I actually would get this. That's why I would get the red. And so this is what's called infinitely many, because literally all these are points. Okay, all these are points. Every single one of these is a point that they intersect at. They cross. Okay, the blue and the red line cross on. Look at all these points. Those are all these are just a couple of points that they cross at. Look at that. Tons of points, right? Yes, and so that's why we call it infinitely many. Now let's erase. Let's go to what a no solution looks like. A no solution looks like this. I'm going to solve it by the method of my choice. So don't get angry if I'm going to solve it using substitution. Just kidding. I'm going to solve it using elimination. But in order to do that, I need to kind of put it in standard form. So this is 5x minus y equals negative 8. Now notice what I did here is I just subtracted the y over. And this one I'm not actually going to change at all. I'm just going to rewrite it. Now what do you notice? What you should notice is that they're literally the exact same, okay? Almost the exact same, just very different, okay? And the constants are literally the only thing that's different. Now, if I change this one's negative, just like what I do, I multiply by negative, and then that goes poofy, I'm left with 0 equals, and this is negative 10. Now, this is, of course, a no solution set. But what does this mean? This means that they're parallel lines. Okay, so this means that they are parallel lines. What does that look like on Desmos? Well, let's find out. Okay, turn these off. Let's plug them in. So I plug in 5x equals y minus 8, and my next one was 5x minus y equals 2. Now look at what this is. Okay, even if I zoom out, they never intersect. Ever, 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 ever. I'm already going into the thousands right now. I'm about to be into 2000s. Okay? I can keep going, keep going, keep going, keep going, keep going, keep going, keep going. They never intersect. And I'm almost at 10,000, I'm at 9,000 right now. You understand? So that means there's literally no solution because they don't have a solution set. They never intersect. And in order to have a solution, they have to intersect. Okay? Awesome. So let's erase this. Now let's get to some word problems. I have 3 word problems and then we are going to be done. So this first one is just 3 times a first number. 3 times a first number decreased by a second number is 17. So let's get used to actually reading the math. What does it look like in English? This. So 3 times. Well, 3 times a first number. What's the first number? Well, we don't know it. Let's just call it x. What's times? Well, that's a multiplication symbol, so dot. 3 means 3, of course. Decrease means subtract, okay? A second number, do we know that number? No, let's just call it y. And then is equals, and then 17. What did we just do here? What we just did was we actually developed an equation, okay, from English. So this is 3y. Sorry, not that. This is 3x. And then minus y equals 17. Now, what's my other equation? Let's read it. First number, increase. So do we know the first number? No, but we called the first number x. So let's call it that. First number increased, what does that mean? Plus. So plus 3 times a second number. What do we call the second number? Y is equals 9. So some number x, right here, first number x, plus 3 times y, a second number, equals 9. Sweet. So this is what we get, okay? And so now what we can do is we can basically substitute this beast. So I'm going to substitute this, okay? I'm going to put it right in there. So this is 3 times negative 3y plus 9, just substituting it in for that, equals, sorry, not equals, minus y. I forgot the minus y. I'm not going to color code here. I hope that's okay. Minus y, that's what minus y is, equals 17. I start to distribute, so this is negative 9 plus 27 minus y equals 17. The negative 9 and then the negative 1y, they go to town, so this becomes negative 10y. I subtract that over, and that actually gives me negative 10. Negative 10. So negative 10 divided by negative 10, so y equals 1. Okay? Now I'm going to take this 1 and I'm just going to plug it in right there. So that means x equals negative 3 times 1 plus 9, negative 3 plus 9. So what does this equal? 6. What's my final answer? My final answer is 6 comma 1. Boom. Okay? So that's how you do a word problem, what we call a translation problem. I have 2 more questions on the application side of it, so you can be thoroughly prepared for your homework. Okay? So let's look at it. Looks a little bit scary, but it's not. So use the functions given below to solve the problem. C of x represents the cost in dollars of x units of a product, and R of x represents the revenue. So revenue is like the selling price. Okay, now I hope you guys know there's a difference between the cost of something and then how much you sell it for. That's how Starbucks makes money. It only costs them like $3, literally, to make the drink. However, they need to make money, right? So they sell it. They have a revenue of more. They should have a revenue of more than what it costs in order to make money. That's why they sell a Starbucks drink, a Frappuccino, at like $5.30, $5.30, or $5.70. Okay, now I want a Frappuccino. All right, so that's how Starbucks works. Okay, so now what does this mean? Find the number of units. That's what it's asking. Find the number of units that must be produced and sold in order to break even. Now, what does that mean? Okay, well, first of all, this is what it means. When my cost equals my revenue. So the cost of a function, when the cost of something, let's just say Starbucks Frappuccinos, when the cost of a Starbucks Frappuccino equals the revenue that's making, okay, that's when it's called break even. If you own a car, if you get in a car accident, and sometimes when you get in a car accident, it's what we call the car totaled. Not every single time when the car gets in an accident, it's totaled. But what it means to have a car when you get in an accident and the technician, the mechanic says it's totaled, what that means is the car's value is either equal to, like this, or actually less than it would be to actually fix the car, which means the cost to fix the car is more than the revenue, okay, is more than the actual amount it's worth, okay? And the same thing here. What if, it costs Starbucks $5 to make a Frappuccino, but they're selling it for $3? They're losing money, right? They need to have a higher revenue. Okay, they need to have a higher revenue in order to pay their employees' salaries and in order to buy new products, to pay for marketing and all that fun jazz. So that's why coffee, even though it's really easy to make, they charge you like $2 to make it. Okay? So what does this mean? It means when they are actually equal. So money coming in is equal to money going out. And this is a very bad no-no. If you take Mr. Power's economics class, you'll know this. Okay, this is what we call the break even. Okay? This is what we call the break even point. And it's something that you don't want happen. So, they want us to know how many units, find the number of units, X, that must be produced in order to break even. So what does this mean? We equal them. So 40,000 plus 36x equals my revenue, which is 40x. And then I just solve. I subtract that over. So this is 40,000 equals 4x. I divide by 4, divide by 4. What does x equal? X equals 10,000. So what does this mean? This means the business needs to be producing, needs to produce and sell 10,000 units in order to break even. In order to make money, they have to sell more than 10,000. Okay? They have to produce and therefore also sell more than 10,000. So if Starbucks comes out with a new drink, right, that means they do their financial analysis and they need to discover, okay, how many units, how many Frappuccinos do we need to sell in order to make money on this? Okay, because it took this much to make. How much do we need to sell at this price? If this is the price, how much do we need to sell in order to make money on this? And then financial analysis mathematicians go in and actually do this math. Okay, so this right here is what we call the break-even point, 10,000. Hope that helps a little bit. Let's go through one more. This one's a lot easier. So you invest in a new play. The cost includes an overhead of $36,000, $36,250, which is a lot, plus production costs of $2,500 per performance. So sold out performance brings in about $3,000. So then let X represent the number of sold out performances. We want to know what the cost function is. So the cost function, C of X, what is that? Well, the fixed price is this. This doesn't change, right? It's not variable, which means it's not per something. It stays as it is. So that means this is 36,250, but added to this plus, that's what plus means, right? Plus the variable cost. the $2,500 per performance. So depending on how many performances you have $2,500 per performance. That's the cost function it takes to actually produce this play. Now, what's a revenue function? How much should we sell these tickets for? Well, sold out performance brings in $3,125. So this is $3,125 per sold out performance. Okay, so per sold out performance, it brings in this much. So we want to determine then the break-even point. That's for C. So C, what's the break-even point? Again, we just take C of X equals R of X. So now what is that? That's my C of X, which is $36,250 plus $2,500 times X equals, and then my R of X, which is 3,125X. I start to solve, okay? And so by solve, I can subtract that over. So I have 36,250 equals, and I have 625 on this side left over when I subtract those two. And then when I divide by 625 to both sides, I get X equals 58. And of course, I can just do that on Desmos, plug it into Desmos, divide those two, that's fine. Remember, make sure you are using Desmos. You can absolutely use Desmos not just for graphing, but for just calculations. If I want to know what 36,250 divided by my 625, I can do that. So 625, and then it gives me 58. Remember, Desmos is a calculator, okay, not just a graphing calculator, okay? Yes, it graphs the calculator for us, obviously, right? Okay, duh. But it's more than that. It actually solves equations for us. So 58. 58 is what we call my break-even point, and I'll abbreviate BE. This is my break-even point, okay? Awesome. So what did we learn today? We learned quite a bit, sort of. So we learned to decide whether or not an ordered pair is a solution. And if it is an ordered pair, we said it was a solution. If it crosses, if it intersects, solve the linear system by substitution. We found the steps to do that by elimination, or what we call the addition method, same exact thing. We identified systems that do not exactly have one ordered pair solution, so that's a no solution or an infinitely many solutions. And then we solved problems using systems of linear equations. Awesome. You will have a homework quiz tomorrow, guys, 2x2 linear systems. There will be some word problems on there. I'll review those during the bell work, though, tomorrow when we go through 3x3 linear systems. Not something Desmos can actually help us with. But there may be a trick Desmos may help us with. But maybe I'll be nice and I'll show you that. But maybe I won't. Maybe. I don't know. But until then, guys, this is C Squared Mathematics. This is Mr. Carlson. Peace out.